Question number 6 deals with what? You have to find out, yes, current flowing. Circuit is R and L. In the previous questions you have covered resistance and inductance isolated, or you can say ideal. Practical coil or a solenoid is a combination of resistance and inductance. So the circuit is, you have a resistance and inductor, and if you apply alternating current AC, then again the question is same. Current flowing is of what type? That is what the question is. Applied voltage is V, and the wave shape of the applied voltage is a sine wave. This is how voltage varies with the time. What you have to find out is current I. Applied voltage is V. Voltage across the resistance is VR. Voltage across the inductor is VL. Applied voltage is V. 2 minutes with you. Notes बंद कर दो. One full page. One full page. In step 1, we draw the diagram to explain the problem. Given problem is voltage applied is V. You have to find out current, magnitude and phase relationship. Step 2, mark voltages V, VR, VL, and mark current. It is a series circuit, only one current I is there. So 2 minutes to complete. Step 3, all the questions, remaining questions which deal with the step 3 is same. You have to mark or draw voltage triangle or phasor diagram for voltage, same. So now you have how many physical quantities here? You can say voltage, applied voltage, that is alternating current, alternating voltage, domestic supply connected across a solenoid, you can say, which is a combination of resistance and inductance. So you have applied voltage V, I, VR and VL. What should be taken as reference and why? There is a relationship between VR and I, there is a relationship between VL and I also. What should be our reference and why? Why do you take ground or road as a reference? Because it is common for all. What is common for all? Current. I is common throughout. That is why I take current as reference, I. If I take current as reference, there is a relationship between current and voltage across resistors, only this part. If I mark this current to be like this, I, how do you mark VR as? Yes, for resistance, voltage and current are in phase. So, voltage is VR. So, I and VR are in phase. That means, if I is taken as reference, then here it is VR. VR is a phasor, it is not a vector. Now, we refer to the next part. If I take current as a reference, I, for an inductor, current lags voltage. If current lags voltage, current has to be 90 degree before that. That means this is the diagram. Current lags voltage. That means in case you mark it here, this is the current, then the voltage. Current lags voltage by pi by 2. So, whether I draw it here, that is, if you take this current as reference, VR, VL is to be marked at this point. Here current is in phase, current lags voltage by pi by 2. 2 minutes to draw VR and VL. Relationship, total applied voltage V is equal to VR plus VL, but this is not a simple algebraic sum, it is phasor sum. That is, as per Kirchhoff's voltage law, V is equal to VR plus VL, but it is not algebraic, simple algebraic sum, it is phasor sum. That means, if this is 3, this is 4, the total is not 7, the total is not 7. We need to take into account the phasor aspect. Now, V, VR and VL, 3 vectors, phasor sorry, V, VR and VL. We now redraw all these. Current is I, VR, yes, VR is in phase. So, this is what VR is. VL and I are 90 degree apart. So, VL is here and V is equal to VR plus VL. Phasors follow law of vector addition. If this vector is A, another is B, the resultant is, yes, A plus B along this line. So, V. Let this angle be theta. Draw voltage triangle. This is termed as voltage triangle. Draw voltage triangle. As an example, just for concept clarity, if VR is equal to 3, VL is equal to 4, V is equal to what? Is it 7? No, it is not 7. It is, if this is 3, this is 4, then if this is 3, this is 4, this part is not 7. It is what? 3 square plus 4 square under root comes out to be 5. So, V competition question, it is not 7, it is 5. Most commonly answered wrong answer is 7. It is not 7. It is phasor sum. So, this step 3 is to draw the voltage triangle. Step 4 is to draw impedance. Again, it means opposition. Resistance, 10th class, Ohm's law, V is equal to IR. Resistance is opposition offered by a wire. Inductive reactance, opposition offered by an inductor. Capacitive reactance, opposition offered by a capacitor. And impedance is a common name given to all these. How? See, VR is equal to what? Let us focus only on this part. VR is equal to what? VR is equal to I into R. VL is equal to I into XL. This is equal to IR. This is equal to IXL. And V, total voltage applied, total current flowing, opposition offered by all, total electrical circuit, combination of resistance, inductance and capacitance is termed as Z, Z, IZ. So, voltage, this total circuit gives some opposition, this total opposition given is known as impedance, Z. So, V is equal to I into Z. Now, from this information, we have to draw an impedance triangle. Impedance, when I say impedance, that means the units are ohm. From this triangle, common parameters, yes, I, common. So, can I cancel I in every component and draw? If you cancel I, what you are left with is R. Here what you are left with is XL, and here what you get is Z. This angle is theta or phi. What is written in the notes? Phi or theta? Phi. Perfect. We will move according. Yes, it is given as phi. So, I won't write theta. As per the notes, I will write phi. This angle is phi. Again, this was current. This was voltage. Current I lags voltage by phi. Why? It is a combination of resistance and inductance. Z will come out to be what? Z is equal to what? Z is equal to, yes, as per Pythagoras theorem, square of R, R square, square of XL, XL square under root. So, Z is equal to R square plus XL square under root. 2 minutes with you to draw impedance triangle. 2 minutes to draw. Step number 5 is what? Phasor diagram. Phasor, I will say phasor, that means wave shape. Current lags voltage by phase angle phi. Voltage was given to you here. Current, if I start from here, then current is in phase with the voltage. If I start from here, then current and voltage have phase angle pi by 2, 90. Here, phi, let me think of 30 degree, then current lags, this is I, lags voltage by pi. If phi is equal to 0, the two are in phase. If phi is equal to pi by 2, current lags voltage by pi by 2. 1 minute to draw. Current lags voltage by phi. Current lags voltage by phi. Discussion. Again, if a V voltage is represented by Vm sin omega t, then current is Im sin omega t. Yes, his difference is phi. Current lags, so minus. For discussion, first possibility, pure resistance. If it is pure resistance, R is there, R is non-zero, but inductance is not there, XL is equal to 0. Then Z is equal to what? R square plus XL square and root is equal to R square plus 0 square. This part is what? 0. So what you are left with is R. In this triangle, yes, say impedance triangle. Now this is impedance triangle. In this triangle, R is there, say 3, XL is equal to 0. If you reduce this side to 0, then this phasor shifts from this position to this position. Phi is equal to what? 0. If Z is equal to this R, then tangent phi is equal to XL by R is equal to 0 by R is equal to 0. Phi is 0. What does it mean? Here in the diagram, if phi is 0, means what? If phi is 0, it means if this is the voltage waveform, then the current waveform is, yes, current waveform is in phase. V and I are in phase. Two minutes with you to write. It is what? Question number 3. That means if you know question number 6, and if you put XL is equal to 0, you are left with pure resistance network. So that reduces to question number 3. Pure inductance. XL, which is equal to L omega. L is 0. XL is equal to L omega. L is 0, so XL is 0. But R is not equal to 0. Then Z is equal to what? Z is equal to R square plus XL square. XL, sorry, pure inductance, no. XL is not equal to 0. Sorry, R is 0. That's fine. Resistance is 0, only inductance, that means the wire is superconductor. So Z is equal to what? XL. If Z is equal to XL, if you, in this triangle, if R is equal to 0, that means this side reduces to 0. If R is equal to 0, XL by 0, XL is non-zero by 0 is equal to what? Infinity. Phi is equal to what? 90 degree. Pi by 2, that means what? Yes, voltage V. Current, yes, phi is 90 degree, pure inductor, current lags voltage by pi by 2. So it is what? It is a case of a pure inductor. Question number 4. Time with you 2 minutes. 2 minutes to write. Numerical number 23. Please refer to the book. Numerical number 23. Question is, when a series combination of inductance and resistance are connected with a 10 volt 50 hertz AC source, a current of 1 ampere flows in the circuit. The voltage leads the current by phase angle of pi by 3 radian. Calculate the value of resistance and inductance. Write what is given, what is required. What is given, what is required. Applied voltage, yes. It is a RL network, so diagram is same. Applied voltage 10 volt. Frequency 50 hertz. Current flowing 1 ampere. What else? Anything else given? Phi. It is given voltage leads. Agreed? You have to write it as current lags. If a current lags, circuit is inductive in nature. Current lags by what? Pi by 3. That means what? 60 degree. What you have to find out is, yes, resistance, you have to find out R and inductance L. Is there any relationship between V, I? Yes? V by I gives you what? Step 1. Z, total opposition offered by the circuit. Z. Z is equal to what? V by I, or V is equal to IZ. Find Z or Z. Total voltage divided by total current gives total opposition offered, which is termed as impedance. Z is equal to what? 10 divided by 1, 10 volt by, comes out to be 10 units ohm. All opposition, resistance ohm. Inductive reactance XL is also in ohm. Z now is known to you. Angle in this triangle is known to you 60 degree. Step 2. That means now it is your school question. Z is given as 10. Focus on this triangle. All questions in competition deal with voltage and impedance triangle. In this right angle triangle, this side hypotenuse is given as 10. Phi is given as 60. Can you find out R and XL? Step 2. Find R. R by Z is equal to what? Base by hypotenuse. Cos 60. R is equal to Z cos 60. Z is what? 10. Cos 60 is how much? 1 by 2. So R is equal to what? 5. Try for XL. Try for XL. Step 3. Yes, XL by Z. Yes, XL by Z sin 60. XL I don't know. XL is L into omega by Z. Z is how much? 10. Sin 60 is how much? Root 3 by 2. L omega is equal to what? 10 root 3 by 2. L I don't know. Omega is what? 2 pi f. F is 50 hertz is equal to 10 by 2 is what? 5 root 3. Solve and find L is equal to what? In Henry. L is equal to what in Henry? L comes out to be approximately 27.6 Henry. Solve, confirm, 27.6 Henry. Confirm.